we are going to see about the topic rational numbers. In lower classes, you have studied the numbers. What is numbers? Okay. In maths, there's many ways. In lower classes, you have studied about whole numbers, integers, natural numbers, etc. Now we are going to say about rational numbers. Before that, we rewind the topic whole numbers, integers, okay, whole numbers. What is whole number? The number start from 0, 1, 2, 3, etc. It is called whole numbers. What is integers? Integers is nothing but including negative numbers. Say that -2, -1, 0, 1, 2, 3, etc. Both negative numbers and positive numbers and 0 is called integers. Okay. Now we are going to see about rational numbers in this video. What is rational numbers? Rational number is defined as P by Q, where P is denoted as numerator and Q is denoted as denominator. The numbers which is represented in the form of fractions, integers, etc. This numbers is called rational numbers. We can say minus 1 by 2, minus 3 by 2. This line will be, it is called rational numbers. Rational number has both integers, whole numbers, natural numbers. So that's a rational numbers, including fractions. That's a rational numbers. Okay, now we are going to say about the properties of for these numbers. That closer, commutative, associative, distributive. What is closer? Meaning of closer. Synonyms for closer. We can say that it is a closed. It is a shutdown. We can say that this is closer. For in mathematical, how is the say that number is closer number? We can take any numbers like that. A comma B. That A numbers belongs to which numbers? Maybe it is a whole number, rational number, integers, anything it is a belongs to. Belongs to means that numbers is a whole number or rational numbers. Anything we can say. In B, B also represents a numbers. If A we take it as whole number means B is also a whole number. If A B belongs to whole number means then the addition, we can say addition, multiplication, subtraction, division. In math, closer, that is A comma B belongs to whole numbers or integers or rational numbers. We can say that A plus B, addition, multiplication also belongs to that number. This is called closer. Okay, say that we have numbers, whole numbers, integers, rational numbers. We have three categories. Closer. Closer means any two numbers. In that we can say addition, subtraction, multiplication, division also belongs to that numbers. For example, if I take whole numbers we can take 0, 1. Addition 0 plus 1 is equal to 1. That 1 is also in the whole number. So 1 and in addition it satisfies the closure property. Next we can say subtraction. For example, 0 minus 1. If I put 0 minus 1, this answer is minus 1. Minus 1 is in the whole number? No. Whole number has no negative number. So in this case we can say whole number does in the closure property. Next, we can say the multiplication. 0 into 1 is equal to 0. So in both whole numbers is a belongs to the whole number. 0 is a whole number. So we can say that multiplication satisfies the closure property. In division, we have to explain in division. For example, if I divide 0 by 1 is equal to 0, belongs to whole number. If I divide the number by 0, if I take 1 divided by 0, 0 also belongs to whole number, 1 also belongs to whole number. If I divide, it is undefined. It has no value. So we can say it does not satisfy the closure property. So whole numbers, only addition and multiplication satisfy the closure property. Similarly, we can say that integers, rational numbers like that. For example, integers numbers we can say negative numbers, including negative numbers, we can say it is a integers. For example, we can take two numbers. One is minus 2, another one is 3. In addition, we can take minus 2 plus 3's answer is 1. 1 is in integer, so it is satisfy closure property. Next, minus 2, minus 3, minus 5 is in also in integers. So closure satisfies the negative numbers. Property is satisfied. Multiplication. Minus 2 into 3, minus 6 is also in integers. So integer satisfied. Division. Division it does not satisfy. Division in integers also we have the zero number. If we divide, we does not have undefined. So division not satisfied. Rational numbers. We are now going to discuss about the rational numbers. Minus 1 by 2 plus 2 by 3. Taking LCM, I get the same rational numbers. So in addition, closure satisfied rational property. Multiplication also satisfies closure property. Division does not satisfy. If in a rational number also have 0, if I divide a number by 0, that define undefined. So in rational number also does not satisfy. What is synonyms for commutative? Commutative is synonyms of interchangeable. We can say it interchanging. If I have in this hand I have pen, in this hand I have pencil. Just I am interchanging pen and pencil. That is called commutative. Likewise, in mathematics we can say a plus b is equal to b plus a. In addition, in subtraction, a minus b is equal to b minus a. Multiplication, ab is equal to ba. Likewise, we can say that here we can divide whole numbers, integers, rational numbers. For that, we can say this commutative properties, how it functions. For example, I am taking two whole numbers, 0 and 1. In addition, if I add 0 plus 1 also, 1 plus 0 also same. So it is satisfied. In multiplication, 0 into 1 also, 1 into 0 also same. So multiplication satisfied. Subtraction. If I subtract 2 minus 3, 3 minus 2. 2 minus 3's value was minus 1. 3 minus 2 for value 1. So these two numbers does not equal. So we can say subtraction does not satisfy. Division is never possible. The negative numbers, including in integers, we have include the negative numbers also. So we can say in addition, for example, minus 2 minus 3 is equal to also minus 3 minus 2. Same answer we get. So in addition, it satisfies. A multiplication also 3 into 2 also 2 into 3 also same. So addition multiplication also say satisfied. Subtraction minus 2 plus 3 same 3 minus 2 a plus b b plus a, but it is not equal. So we can say integers does not satisfy commutative in subtraction. Okay, next we have the rational numbers. Rational numbers, we have say that addition, yes, 2 by 3 plus 3 by 2, we interchange also we get the same answer. Multiplication, same answer. Division, not possible. Subtraction, no, never it will become equal. We get the negative signs. So we can say that going to say about the property associative. What is associative? It is a connections. We are saying connecting. Here we are pairing a plus b plus c is paired. In this a plus b plus c. So we are interchanging the pairs. If it is equal, this can be said as associative property. It is for addition. If we multiplication here instead of plus we use multiplication, subtraction, minus sign, division, division sign. just interchanging the signs. Now we can say for the whole numbers, integers, rational numbers. Addition is satisfied, integer satisfied, rational satisfied. Why? Addition does not have a signs. What is meant by sign? If in subtraction we put a negative sign for greater number. If I subtract 2 minus 3, means in subtraction I put the value minus 1, which is greater. If I subtract interchanging 3 minus 2, I put the sign 1, so which is positive. So subtraction does not be equal. So associative does not satisfy the subtraction sign. Multiplication, it is satisfied. Division, not satisfied. It is not satisfied because we have the number 0. It is divided, we get the undefined value. So we can say division does not satisfy the associative property. Now we are going to discuss about the problems. To simplify this calculations, here denominators all different. We have to make the denominators are equal. We can do this calculations in two methods. One is normal LCM method, another one using the properties. Now first we are going to solve by LCM method. We having four numbers. What are they? 7, 11, 21, 22. Just finding LCM. LCM is find by prime factorization. What is prime number? Prime number is divisible by 1 and itself. So 7 is a prime number. So 7. 11 is also prime number because it does not divide by any other number. So 21. 21 is divided by 7. So we can write it as 7 3s are 21. 7 is also prime, 3 is also prime, no problem. 22. 11 into 2. 11 also prime, 2 also prime. So no problem. So we have to write list 7, 11, 3 into 2. So just multiplying this numbers. Okay, 11 into 7, 77. 3 2s are 6. Just multiply 77 into 6. Into 6, 462. So LCM is 462. So we get 462. Here we have 7. When did we have denominator 462? Now we find the common divisor 462. So we have to make this conversion into 462. When did this 7 become 462? Just to divide 462 divided by 7. 7. 7 into 66 we get 462. Just multiple 3 into 66. 698. Okay, next we have to find 11. So divide 462 divided by 11. 8. When we are multiplying, we get 176 plus 62, 21 times. So when 21 into 5. When simplifying this to minus 252. 198 plus 105, 252 plus 176. By adding, we get 303, 428. By simplifying, 428 minus 303, we get 125. Which sign is greater? Minus 428. So we are including minus sign. So answer is minus 125 by 462. Here we can make a mistakes. It is a very big calculations. Now using the properties, we can easily solve the answer. How we are 11. So this two has common divisor. This two has common divisor. By commutative property, just we are interchanging. What is commutative meaning? Commutative meanings is interchanging. So just interchanged. So 3 by 7 minus 8 by 21 plus minus 6 by 11 plus 5 by 22. Here we taking 7 comma 21 LCM. 7, 21, 7 into 3. So LCM is 21. So 21. When it is 7 become 21 3 times. 3 3 is a 9. 9 minus 8 plus. Here common LCM becomes 11 22. When it is become 22, multiplying by 2. 6 2s are 12, minus 12 plus 5. So 9 minus 8, 1. 1 by 21 plus 22. Just multiplying 21 by 22. It's have no common factors. So cross multiple 22 minus 7 into 21 by 21 into 22 we get 462. So 22 minus 21 into 7 minus 22, 7 to 4, 4 to 125, greatest sign minus, so minus 125 divided by 462. So we get the same answer in different methods using the properties. Next we are going to say about the distributive property. Distributive means just a sharing the numbers for both B and C. That is called sharing. A into B plus A into C. In mathematics, we're using addition and subtraction, but normally distributive means sharing. So A is shared for both B and C. This is distributive properties. Using this, we can solve one problems. It is A cross B plus B cross C. A cross C. That's it. Here 3 by 7. Here is also 3 by 7. So now we can join this. 2 by 5 into minus 3 by 7 plus minus 3 by 7 into 3 by 5 minus 1 by 14. It is leave it. So this is A cross B, A cross C. So we can write it as A cross B plus C. So minus 3 by 7 into B plus C. Both common. Minus 3 by 7 is common to both factors. So we take minus 3 by 7 is A into B. B what? 2 by 5. C what? 3 by 5. So just we are make it as minus 1 by 14. Now we can denominators both are same. So just add the numerators. We get 5. 5 by 5, 1. So minus 3 by 7 minus 1 by 14. So just taking LCM for both numbers, we get 14. Likewise, 7 is prime factor, 14 is 7 2s are 14. So LCM is 7 into 2. So 14 is a LCM. When did become 7 become 14 means multiplying by 2 we get 14. So numerator minus 6 minus 1 minus 7 by 14 is equal to minus 1 by 2 is the answer. By using distributive law, we can easily simplify it. Thank you. If you like this video, press like button and share it for your friends. If you want more videos, subscribe it, and you have any doubts, comment in the comment box. Thank you.